Okay, in this video we are going to finish section 3.3, and before we go to the last parts of section 3.3, I would like to give you a few more examples on the chain rule. Okay, so let's see how do we take the first derivative of this function. So if I have 3t to the third power minus t in order to the fifth power. So the question asks you to differentiate. So this word means that take the first derivative or take the derivative of this function. Okay, or differentiate, just the same thing as take the derivative. Now remember, in this case we are trying to take the derivative with respect to the variable t, right? Usually we have x, but the book use t. So in this case we're taking the derivative with respect to t. Now remember, we see that the outside function is the one that's to the power of 5, and the inside function is what you have here. And imagine if you have t to the fifth or x to the fifth power, then we can use the power rule. That's easy. But now the inside function is not one variable, it's another expression. So we call this whole thing here maybe u, right? So we call this whole thing here inside is u. Now we have to take, so now we have u to the what? U to the fifth, and then we differentiate that. That means we take the derivative of this one, and it's easy. This is a power rule. You bring down the 5, right, and you subtract 1 from 5, which is 4. But remember, because we let u equal to this thing, we have to differentiate that one more time for the u prime. Okay, that's the chain rule. Okay, so imagine I call this whole thing here no, let's just stick with the u. So after you take the normal differentiation, then we multiply with the chain rule of u, which is u prime. Now u is this expression. U prime is what? U prime is the same thing as du over dt, because u is the function in terms of t. So we take du dt. Alright, so just apply the power rule again. Bring down 3 times 3 is 9, subtract 1 from that, 2, minus, this is t to the first power, bring down the 1, and 1 minus 1 is 0, t to the 0 is 1, so we just have minus 1. So u prime is 9t squared minus 1. Now u, at the end we have to convert back everything in terms of t, because your original function is in terms of t. So now u, we can plug in this whole expression back. So 5 times t cubed minus t, and then to the 4th power, and then u prime is this one. So 9t squared minus 1. So that is your answer. In the textbook, they call this u is z, but I would like to call it a u, because I remember I talked to you in the class before with a u. So let's to be consistent with that. But you can use whatever letter you like to. At the end, we should get the same results, right? If you use z, then in this case we have z prime or dz over dt. Same thing. We have to take the first derivative with respect to the t, because your original function is in terms of t. Wait, okay, let's go. Okay, let's have another example. I have this function ln of q squared plus 1. Okay, now we are asking to differentiate or take the derivative of this function. Now, remember, if I have ln of x, and then if I take the first derivative of this function, or the prime of this function, I will get what? 1 over x. So ln of x, when you take the first derivative, you just have to put 1 on the top and then x at the bottom. This is the rule, the formula for the natural logs. Okay. Or if you have ln of u, right, then if you take the derivative of this one, you have 1 over u. So whatever the variable here, you just put 1 over that. That's the rule. Now, in this case, we don't have that, right? Your inside function is not one variable, it's another expression, and your outside function is the ln. So you let your inside function equal to whatever the expression they give you, q squared plus 1. Now you have what? You have ln of u, right? And now we are trying to differentiate that, or we take the first derivative or the prime. Remember, ln of u just 1 over u. That's the rule, right? 1 over u. But remember, we let u equal to this whole thing, so we have to multiply with u prime for the chain rule. And u prime in this case is du over dq, because your original function is in terms of q, right? Now q here is q to the power of second, so bring down the 2 and then subtract 1 from that. 2 minus 1 is 1. 1 here is the constant. You take the first derivative, it gives you 0 or just 2q, right? So now let's put back in here and convert back everything in terms of q. 1 over u is this expression, q squared plus 1. U prime is 2q. Multiply with 2q. So this is your answer. Easy. So if you have ln of x, you take the first derivative, it gives you 1 over x. That's the rule. So make sure you know that. In another ways, you can think of this. You take the derivative of your outside function first, which is 1 over u. Then you take another derivative for your inside function. That's the chain rule. Okay, and it will make more sense for this example. Okay, I have this problem. We are given h of x equal f of g of x. This is a composite function, right? And then we have a function k of x is g of f of x. Okay, and now part A, they ask us to find h prime of 1, and they give us f of 1 equal 1, f of prime of 0 equals 0, f prime of 1 equal 3, and g of 1 equals 0, g prime of 1 equals 0. Sorry, equal 1. Okay, so h prime of 1, that means we have to take the derivative of function h and then plug in the value of x equal 1. Now the function h we are given here, so h of x again f g of x. Now your outside function is f and your inside function is g. So if you take the derivative of this one, you take the derivative of your outside function first, which is f prime, right? F prime, and you have to multiply with your derivative of your inside function. That's the chain rule, which is g prime of x. So you take the derivative of your outside function, which is f prime, multiply with your inside function, and then take the prime of that. That's the chain rule. Now h prime of 1, that means the value of x now become 1, the one we're looking for. So f prime g of 1 multiply g prime of 1. Remember, g of 1 give you 0. That means you plug in the 0 for here. So f prime 0 multiply g prime of 1. F prime of 0 is what? It's 0. Multiply g prime of 1. G prime of 1 is 1. But 0 times 1, just 0. So the value is just 0. Now, another part, they ask you to find k prime of 1. So remember, k is this function. So k prime. Remember also we have the outside and the inside function. So take the derivative of your outside function, which is g prime, first. Multiply by the derivative of your inside function, which is f prime of x for the chain rule. Okay. So the value of x here is 1, right? So I also plug in f of 1 here. F prime of 1 too. Now f of 1 given here is also the value for 1. So we have g prime of 1 multiply f prime of 1. Okay, so finally g prime of 1, which is 1, multiplied by f prime of 1, which is 3. So 1 times 3, 3. So final value is 3. So remember, if you have the composite function, so always, if you take the derivative of this whole function, take the outside function, and then multiply by the derivative of the inside function, which is the chain rule. Alright. Now, the last topic for this section is the relative rate and the log. Okay. Logarithm. Okay. So what does it mean when you say the relative rate of change? So by the definition, the relative rate of change. So for example, if I have z equal function f of t, then the relative rate of change is equal to the first derivative of the function f over the original function. Or you can say the ratio between your first derivative and your original function. Now, remember, if I want to text f prime, this is the same thing as I take z prime. Okay, and let me try to simplify this expression. So remember, from previous slices I showed you that if I have a1 of x, then if I take the prime of that, I get 1 over x. So the same thing here. If I have a1 of, let's see, if I have a1 of z, right, and z is this function, okay, then if I take the prime of this, which is I take the first derivative of this function, z is the function of t. Now I would have 1 over z, and then I multiply with z prime, because z now is function of t, or z prime is dz over dt, or 1 over z and dz over dt. Okay, so basically the same thing as your u. We usually call this u in the previous example, but now the textbook they use the letter z. So let's try to be letter z and see the result of that, which does not change anything, right? So 1 over z and then z prime. Before we have 1 over u and the u prime, but this time we are using the letter z. So 1 over z and z prime. 1 over z, z prime is dz over dt. Okay? So we can write that the ln of z prime. If you take the z prime, the same thing as you take d over dt of this whole thing. Okay, they are equivalent, right? The prime is means taking the first derivative with respect to t, because your original function is t. Okay. Now, so I know that the f prime. So f prime is z prime, right? And z prime. Now, let's me try to simplify the expression so it's make more sense for you guys. So f prime of t over f of t. F of t is what? F of t is z. So let's rewrite that as z, right? F of t is z. On the top, we still have f prime of t. Now, take a look at this one. 1 over z and f prime of t. That means dz over dt, right? So f of t, f prime of t. So if I take f prime of t, that means I'm taking z prime of t, or f prime of t, the same thing as what? dz over dt. Does that make sense? Yes. So f prime of t, I can rewrite that as dz over dt. So dz over dt. And then we still have 1 over z. So now, this whole thing, the rate of change now become what's 1 over z dz over dt. Okay? And 1 over z dz over dt. So basically, we are just taking the derivative of ln z. Right? So the whole relative rate of change now basically just taking the derivative of the ln of the function z, or f of t. Okay? So if I ask you to find the relative rate of change of the function f of t or z, we are just taking that first derivative of the ln of that function. That's all we have to do. Alright, let's try one example, and then hopefully it will make more sense. Okay, so this example, they're asking us to find the relative. Okay, so by the way, if you are watching up to this point, that means you are finishing this video. Make sure email me and then say that you watched the video. I'll ask 1 more point extra credit for your midterm score. Okay, let's keep going. So find the relative rate of change of the exponential function z equal p naught e to the kt. So remember, if they ask you to find the relative rate of change of something, right, in this case z, we just have to find d over dt of the ln of z. That's all. Because the z here is in terms of the function t, kt, right? So we are taking the derivative with respect to t of the ln of the function we are looking for. That's all we have to do. Now, the first thing is they give you this function. So let's try to find the ln of that. Okay, so ln of z, that means I'm taking ln of this whole thing. Okay. Now, this is the multiplication, so I can use a property to split them up. It's become addition, right? So ln p naught. Now ln and e, they cancel each other, give you k and t. So this is ln of z. Now we take the derivative of this with respect to the t term, which means we are taking this whole expression, right? We're taking the prime. So this ln of p naught, this is just a constant, so it becomes 0, right? P naught is just some constant. ln of a constant give you a constant. You take the derivative of that, give you 0. Now, we are taking this z with respect to t, because your original function is in terms of t. Now, this is a t, so t to the first power. So bring down the first time k as it's k, and then minus 1 from this, t to the 0, which is 1. So we just have 1. So if you take the derivative of this one, it gives you just k, right? So basically, you take d over dt of this ln of z, it's give you k, or your relative rate of change of the exponential function, just the k. So whenever they ask you to find the relative rate of change, you just have to find the first derivative of the ln of the function they are looking for. So they give you this one, you find the ln of that, and then take the first derivative. That's all you have to do. Okay, so that's the end of section 3.3.